Okay, so let's look at this. Let's look at problem. Okay, let's look at this problem number 1. Let me make sure it does it right. Yeah. Okay. So let's look at this problem. And then let's look at is that what I want to do? No, that's not what I want to do. Sorry. That's the one I want to do. Excuse me. And then let's look at x is equal to -2. And then the command for this will be solve. By substitution. So let's think about this. We've done this problem before. What we do is anywhere there's an x, I put a parentheses. And then in the parentheses, I'll just put the value of the variable, and you'll get 8 minus 4y is equal to -4. And then when I subtract 8 from both sides, I'll get -4y is equal to -12. And then I'll divide both sides by -4. And then I'll get y is equal to 3. Okay. So we started out the class with about 50 students. We're down to about 25 today, day after the quiz. And that's pretty much what happens. Now, you don't have to copy what I'm going to write, okay? But for those of you who go into calculus, this is sort of what happens. You have 125, then you have 259, and then you get 261, 262, and then 263. Okay, so this is Algebra 2. This is trig pre-calc. This is Calc 1. This is Calc 2. This is Calc 3. Okay. Now, the pass rate for this class is about 50%. The pass rate for this class is about 40% right now. Pass rate for these classes are 50%, 50%, 50%. And this isn't because Valley College sucks. This is what the numbers are nationally. These are also what the numbers are at the Cal State. So if you go to Cal State, you'll see exactly this. If you go to any other community college in this country, you'll see exactly this. If you go to UCLA, it's a little bit different, only because most of the people coming into UCLA have accomplished this in high school. So they're almost done with that track. Now, once you get past Calc 3, you'll take different differential equations. And the pass rate for this is 95%. 95%. In fact, every class after this is 95%. Once you get to here, you kind of know you're going to be an engineer. You kind of know you're going to make it. Okay, So for most of you who are trying to be a science major, engineering major, math major, physics major, this is the big road that you're trying to do. Now, when you look at who makes it, if you look at sort of the data behind it, okay, so you have A, B, C, D, F. So normally what happens is the A's stay A's. The B's in this class turn into C's, and the C's in this class turns into D's. Okay? And then what happens is you retake it, and you get an A or B, right? If you flunk it, you get an A or B, and if you're an A, the A's stay A's, and then the B's in the next class go down, right? And then the C's flunk. Okay. So if you're trying to make it your business to use math as a way to make money, it's really important that you shoot for that A, because this is the slog that keeps everyone from making it, because it's 1, 2, 3, 4, 5. Every time you take a class, we make it faster, right? Because your job isn't to do the math that we teach you in this class. Your job is to read something new in your field, learn it, run with it. And we need you, if you're going to be an engineer or a mathematician or a physicist, your job is how fast can I read math, understand it by myself, because I'm not going to have a teacher, and feel comfortable with it, and then apply it, and then put it in a car engine. Okay? So for those of you who are trying to make it to some kind of STEM field, you got to shoot for an A. The A's go all the way through. They don't drop for the most part. You're an A here, you go A all the way through, right? Okay. Now, let's look back at sort of what we just did. This is something we've been doing for a long time. I've got this equation with two variables. I plug in a value. I figure out what the other thing is, and then I get this as an answer. And then the answer is this point. And when we're graphing lines, we do this all the time. So now let's sort of look, using yesterday's lesson, let's sort of revisit this problem that we've been doing so far. Okay, so let's take a step back and say, well, what if I graph this? I can plug in 0, 0, or I can convert it into slope intercept. So let's just plug in a 0 here. So if I plug in a 0 for x, y should be equal to 1. And if I plug in a 0 into y, well, then x should be equal to 1. So when I graph this, what I should get is something that goes through here and here, like that. Okay. That's what this one looks like. Now, if I were to graph y equal 3, so I'm going to keep going down. Let me see. 1, 2, 3, 4. So this would go down to here, and then to here. It's around there. Okay. So now, if I was to graph y is equal to 3, this is a vertical line. Oh, wait. Oh, I'm sorry. X is equal to -2. My bad. I'm sorry. I'm trying to graph this other line over here. That's what I thought I had. Okay. So if I try to graph this, x is equal to -2, it goes down somewhere like this. I get that point. That's my solution. Okay, so let me give everyone a chance to copy, and then I'll try to like summarize it because I was kind of stuttering while I was doing this. Okay. So we've seen this problem before when we're graphing that they give you a line angle x is equal to -2. Now we've learned that we can find the solution by graphing the two lines. So really what this question was you're drawing one line and then you're drawing the vertical line and you're saying where do these two things intersect? Okay. So this is a problem that we already know how to solve. Let's take a picture of it. Okay. Now that's not what's going to be on your test, right? We've already sort of done this. Let's change this a little bit. And let's do this problem. Okay. Now, this is a little bit different. The reason why is because x before was equal to a constant, and this time I'm letting it equal to an entire expression over here. Okay, so instead of x being equal to a number, it's now equal to this big ugly thing. Okay? So go ahead, copy that, and then we're just going to teach you first principles. Okay. Now, what we did prior is we said anywhere there's a variable, we're going to put a parentheses. Right, so I've got -4, and then a parentheses. Now, in the past, what we put in the parentheses was a number, but just know that this technique works for an entire expression also. So over here, x is equal to 4y minus 14. We're going to put that directly into here.
Professor?
Go ahead.
With those two lines, are those a system?
Yeah.
So would we add a curly bracket next to them, or is there no need?
It's optional.
Okay.
The curly bracket really doesn't do anything for you. It just sort of means that these two things are together. But whether they're there or not, it's still the same thing geometrically.
Okay, got it.
Yeah. It looks pretty though when you put the bracket. Okay. So let's now solve this problem. See, we couldn't solve this problem before because it had two variables. Now this has only one variable because we got rid of the x's in here. So now we can solve this. And then let's see, this is going to be -56. Oh, sorry, +56. Okay. And then we're going to combine like terms. And then I'm going to subtract 56 from both sides. So not only can we substitute numbers, we can substitute entire expressions. Okay, so let me let you guys finish
Professor,
talk about that. Yep.
so the equation started with -20, and then you had to divide by -20. You forgot, and then
The negative. Thank you. You get a plus. Okay. Thank you very much. Okay, so we're not done yet. Okay, but we're almost there. Right. So let me give people a chance to copy and ask questions. So all I did was take this value and I put it in there. Okay, so let's go to the next part. Now, let's, you have two choices. I'm going to plug this in either into here or into here. Now, I know there are a lot of people who took that test yesterday that were really frustrated. Let me just tell you, you're already committed to this class. Like it's already too late to drop. Stay all the way to the end. Okay. There are basically three people in this classroom right now. All right. There are people who are going to pass. There are people who are going to pass in the spring, pass in the fall. And then there are the people who are going to never pass. These guys, I don't care about. Even if you flunk that test, remember, I dropped your lowest score. If you get 75% on the final, I'm going to pass you. Okay, so these guys, I don't care. Let's talk about these guys. Okay. Now, the difference between these guys and these guys is these guys will quit now. And these people will stay for 4 weeks. And then get a W. So let me just tell you, staying in a class where you're overwhelmed sucks. It feels terrible. Sitting there, asking a question, taking another quiz, having that sick feeling, walking through, watching the timer go down, not having enough time, that is the hardest thing to do. The hardest thing to do isn't to go from a B to an A. If you got a B, to get an A, all you do is a little bit more. A little bit more of what you've been doing. Have a little more fluidity and you're probably going to be fine. The hard part is going from an F to a D. You're still not passing. You did a lot of work. You're here every day. But it's just been a long time and I've either never mastered this or it's been a long time since I've mastered it. And you're in an unfair situation because we're just covering too much material in one day. Okay. But if you stay all 4 weeks, the next time you take the class, you've done a whole bunch of homework. You've done a whole bunch of repetitions. You know which sections you're stuck in. And you know during the middle of the lecture exactly what you don't know. So then you raise your hand and you go, that part, that right there, that's what I got wrong. Please explain it to me now. And then you'll remember it better because you took a test, you stared at it, you swore at it, and then it creates a memory. Okay. If you quit now, when you start up in the fall, you're still under skilled. So you're going to get that sick feeling again. And if you quit again, you're just not moving forward. I have students all the time that take this class all the way through, and it just sucks because they flunk all the way through it, but they struggle with it, right? So instead of knowing nothing, they know 50% of it, just half. Imagine if you knew half this material, only had to have study half as much to pass. Okay, so the way the data works is that this is roughly about 50% of the people. This is roughly about 25% of the people. And this is roughly 25% of the people. If you look at the data. Okay. The people who are going to make it in the fall, the people who are going to stay all the way through, and it's going to suck. Now, understand this. Let's say you stay all the way through and you know half the material. That's still flunking. But you know half the material. You walk into fall as a person who knows more than most other people. Most of the people are at 0. And because you know half and you're asking all the questions, guess what? You're the student that gets an A. Once you get an A in this class, you're an A student. You don't have to build up to it. When you go to 227, when you go to 259, you're walking in as an A student. So even though you take this, you get an F in this, right? That second time you get an A, you stay an A student. So for those of you who took the test and it just killed you, it's just, I didn't have enough time. Yeah, you're in an unfair situation. Stay all the way through, get a W at the end, do all the homework, right? Know what you don't know, and then in the fall, take me again in Math 134, and we'll just knock it out and get an A, okay? If you quit now, I don't know that you're ever going to pass. So I'm not worried about these people. My goal is to get as many of these people in here. That's the difference. That's what I'm trying to do. Okay, so if you are here, please email me, ask questions, stay after the class. I'll do homework problems with you. Okay, the people I care about the most are getting as many people who are in here into here. Okay. Okay, so now in this question, we solved one of these, and then now let's plug. You don't have to do both of these. You only do one of these, and this will give you the X value. You pick the one that you think is easier. For me, I think this one's easier, but you could just as well do this. So you go X is equal 4 times 3. X is equal to 12 minus 14. Now, I just want to prove to you that you would have gotten the same answer if you plugged that into here. Equal minus 12 is equal to minus 4. Minus 4x plus 12. I'm sorry. I get minus 4x is equal to 8. So x is equal to minus 2. So for both of these, you got the same answer. Now at the end, you write your answer as a point. Okay. Let's take a picture of that. Okay. So go ahead, copy it, and then let me just make a key point. Okay, now, to solve this problem, we needed 2 line equations. And the key thing was that one of these variables had to be isolated, meaning that I have an x equal or a y equal. It doesn't matter which one it is, but one of them needs to be x equal or y equal. So the next question is, well, what if I what if I don't have something that's x equal or y equal? Well, let's do that question. So let's say I have something that looks like this. Okay, so let's say I have something like this. So my goal is to transform one of these x's or one of these y's into x is equal to something or y is equal to something. Now, it doesn't matter which one you do, except that I hate fractions. So if you had isolated this one, at some point, you're going to divide everything by 3, and that's going to give you a fraction. You'll still get the right answer, but dealing with fractions when you don't have to just sucks. What I would do is most likely is I would isolate this one. Okay. I would isolate either an x or a y. In this case, I would isolate the x. Because if I divide everything here by 3 to isolate this x, I'll get a fraction. If I divide everything by 4 over here, I'll get a fraction. And if I divide everything by 5, I'll get a fraction. So what I want to do is pick the x or y that doesn't give me a fraction. And for the most part, looking at your homework, it looks like every problem is set up so you don't have to mess around with fractions. Okay? So let's isolate this. Okay. Now I'm going to subtract the 5y from both sides. And you'll get x equal minus 5y plus 3. And then 3x plus 4y is equal to minus 2. Okay. So go ahead and do the substitution. What I want you to do is to take this and put it in there. So go and see if you can do that move.
Professor,
Mm-hmm.
isn't there another method where you can multiply the top equation, let's say by -3, to get rid of 3x?
Yes. So we're going to do that one. We're going to do that tomorrow.
Oh, okay.
Okay. So basically, there's 2 techniques. And then the next question someone asks me is usually, do I have to use this technique? And the answer is no. When I give you the test question, you do the one that you like. And like you do the one that you like. The question may say use substitution or elimination, but if you don't have to show work, I don't care how you do it. Just do it the right way. So what we do, just like in graphing, there's 2 graphing techniques. There's plugging in points. There is y-intercept. We always teach you the easier way second. Okay. So if you ask me, well, if you're going to teach me the easier way second, what am I supposed to get out of this? Is that we'll have other sections where we'll take a variable and we'll plug it into here. And in calculus, that technique is done a lot also. So I just want you to get used to the idea of I'm going to take this, I'm going to put it in here. And that's what you're supposed to take away. And if you just learn how to use the other technique really well, I'm fine with that. Okay. So anywhere there's an x, we're going to put in a parentheses. Okay. And what goes in that parentheses is all of this. Okay. Now go ahead and solve for y. Okay, and then you'll go minus 19y. Is that right? Oh, 11. I had a panic attack for a second. Okay. Now you can plug this into any equation that has two variables. So you can plug into here, 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 or here. So you can plug it into here, 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 or here. Pick the one that you think is easiest. Okay, so let's do this. Okay, so we have x is equal to minus 5 times 1 plus 3. So x is equal to minus 5 plus 3. X is equal to minus 2. So your answer is going to be minus 2 comma 1. Make sure the x comes first. Oh yeah, and then make sure you don't do this. This is wrong. You have to make sure you have a parentheses there so we know that it's a point.
Professor,
Go ahead.
when you can plug it into any equation with the two variables, is that what you mean when like by checking your work or?
No, in order to get the other variable. So when I get to here, I know what y is, but I don't know what x is.
Okay.
Okay. So in order to find out what x is, I have to plug this value into either this, or this or this.
So that's basically like three different solution problems that we should memorize in a way.
Well, let me put it this way. So when I get up to here, I only know what y is. So I have the option of solving a few different problems to find x. I can either do x plus 5y is equal to 3, x is equal to negative 2. I can either solve that problem, or I can solve this problem. 3x plus 4y is equal to negative 2, and then, I'm sorry, y is equal to 1. Or I can solve this problem. X is equal to minus 5y plus 3, y is equal to 1. So when I get up to here, I know what y is equal to. I don't know what x is equal to. So I have the option of either solving this, or this. When I put 1 in here, each one of these is going to end up giving me x is equal to negative 2.
Okay.
Right? So it doesn't matter which one of these you solve. You just solve the one that you think is the easiest to do.
Okay. Okay.
Okay.
Thank you.
Yeah. Okay, so let's try another one, and let's give you the whole shebang. And then, just so you know, I just got an email yesterday from a student. She flunked Math 134 with me. She just got an UCLA as a math major. So this is not part of your transfer GPA. If you flunk this class, UCLA could care less, right? So this, if you flunk this, do fine, and then just do fine. Nobody cares, right? So the key is stay all the way through. Just stay all the way through. And then at the end, don't get an F, get a W, a withdrawal. And the reason why is that if you take 134 over the fall, it will not override this grade. The reason why is that the numbers are different, 125 and 134. So make sure at the end you get a W, not an F, because that'll affect your financial aid. Okay. Okay, now let's give you the whole shebang. So let's give you something that looks like, yeah, that's good. Solve 2x minus 5y is equal to 1. 3x plus 6y is equal to 15. Okay. So you have to isolate x or y. One of them. Okay. Now don't write what I'm going to write, but this is how you analyze it. You kind of go through all of them and say, well, if I isolate this x, at some point I'm going to divide everything by 2, and that gives me a fraction. I hate fractions, so let's not isolate this one. Well, when I isolate this one, at some point I'm going to divide everything by -5. And that gives me a fraction. And I hate fractions, so let's not isolate that one. Let's go down and look at the other one. Maybe there's something that works better there. Let's say I go down over here. Now, when I divide all 3 of these terms, I'll get whole numbers, I'll get integers, which is great. I love integers. I hate fractions. So let's isolate this one, the x on the bottom. So go ahead and isolate. Okay, so that's how we figure out which one to isolate. Divide everything by the coefficient, and if nothing turns into a fraction, that's probably a good one to do. So you get 3x plus 6y is equal to 15. And then I'm going to divide everything by 3. I'm going to get rid of the 6y. Bx is minus 6y plus 15. And then I divide everything by 3. All right. So we've transformed this one. Now be very careful. This is the one that we've isolated, so you have to use the other one. Don't use the same variable, the same line twice, because bad things will happen. Okay, so this is the one we're isolating, so we're going to use this one and this one together. Okay. So let's do, make another pretty line. So we're going to use, we have to use this one. And then we have to use that one. So go ahead and do your substitution.
Professor, so we always plug it into the equation, to the one we didn't use?
Yeah, yeah. Now, and in about 10 minutes, I'll explain why that's important. But yes, yes. So for right now, say it because I told you. But in a little bit, I'll explain exactly why. So anywhere there's an x, we're going to put a parentheses. So you get minus 4y plus 10. So I get minus 9y. Then I'm going to subtract 10. And then I'm going to divide both sides by minus 9. Okay. Now plug this into any equation that has two variables. So you can plug it into this one, this one, this one, this one, or this one. Pick the one you think is easier. Usually when you, after you isolate it, usually that's the easiest one. Only because the x is already on one side. You're just plugging the 1 into here. So let's do it again. X is equal to minus 2y. And you go y is equal to 1. So you go x is equal to minus 2 times 1 plus 5. X is equal to minus 2 plus 5. X is equal to 3. So go ahead and copy that. So I know today's a hard day for a bunch of you who took the quiz and then didn't do well and are frustrated. So this is always the hardest day of the semester. It's always after the first quiz. You're always a little overwhelmed. Last semester, I gave all the same coaching, all the same talk, and afterwards I had this mom. She came up to me. She's probably about 30. She had never mastered algebra at all, and she's just in tears. And she just told me, Dr. Kawhi, it's just not in me. I wish I was that girl that sits right over there in front, because she's always asking you questions. She seems to be able to follow you. She totally understands the stuff. It's like she's seen it before. Like, I'm not her. And I told her that, just so you know, she flunked it last semester. This is her second time taking it. She knows all the questions that she got wrong. So the reason why she's asking the question is that she has a memory that, on the test, I screwed that up. Hey, help me right now, because this is what I don't know. She saw half the material. She memorized half the material. She's only having to learn half the material. Now, unfortunately, we're not sitting in a classroom together. But I knew the girl who had flunked once before and was asking all the smart questions. And I said, you know what? She's a really nice person. You guys are about the same age. I bet if you went and talked to her and said, let's study, she would study with you, because I know her from last year. I know she's that kind of person. So the girl did. She went to her and said, want to study? And they said, yeah, let's study. So the thing that was really nice about that is that the girl who had flunked before and was taking the second time, she could warn the other girl, the mom who's taking it for the first time, to say, I got this wrong. So be careful. He likes to ask this question. I got this part wrong. But now that I asked the question, I kind of understand it this way. We don't have that same dynamic because we're doing virtual, but in the chat, if you want to study with someone, just study with someone. Zoom is free for 45 minutes. You can just redo a Zoom. When the pandemic hit, those two, they had already created a relationship. So they were just studying together with the Zoom on, helping each other as they go through homework together. Okay. So I don't know how that works in this virtual world, but if you want to type in the chat, anyone want to study, go study with someone. Okay. It doesn't have to be a solo thing, right? But just know that most of the people, a lot of the people who are asking really smart questions, they're one of two people. One, they're high school students and they've seen this before very recently, or two, they flunked this before and they've seen this just last semester. Okay. So if you're all stressed out, right, just know that the best people in the class have just recently seen it. That's why they're asking so many questions. Okay. So let's get going. Let's do one more of these. Well, actually, I want to sort of double down on the point. So over here, we said make sure you plug this into the other equation. Otherwise, bad things are going to happen. So let's see what bad things happen, and then let's explain why that bad thing happened. Okay. So we isolated this one. We isolated here. So let's plug this back into the equation that we originally got it from. Okay. So imagine that, oops, this is equal, let me write that better. Okay, now, go ahead and try this problem and tell me if anything interesting happens. Okay, so all I did is isolated this, and rather than put it in the other one, I doubled up and put it on the same line that I isolated. Okay, tell me something interesting happens after you substitute.
Yeah, I got a 15 equals 15 at the end.
Okay, you got something weird happening, right? Okay, so we get something that looks like, well, let's put this in here. Right, this is the dogs are sleeping with cats. The world is coming to an end problem, right? Something terrible happened. So now we get -6 plus 15 plus 6y is equal to 15. And then these two will cancel. Oh, I'm sorry. Yeah, I need a y there. These will cancel, and I'll get 15 is equal to 15. Now let me let people copy, and then we'll talk about what that means.
Does that mean is it like the last test where that would mean that's an identity? Or-
Yeah. But how we answer this is a little bit different from how we answered this before. But you said it correctly, that's the identity, yes. Okay, so when this situation happens, remember that we have three situations. We have this one, that's the normal situation where you have one solution. And then you have this one, you have no solution. And then you have this one, where they're the same line, and you have infinite solutions. Okay. So over here, we have no variables. And a true statement. We have exactly what the student said where we have this identity situation. Basically, we have this right here. See, what happened was I isolated this and then plugged it back and compared it to the other line I had, which means that I'm using the same line twice. If you do that, your variables will cancel and you'll get infinite solutions. You got infinite solutions because I'm using the same line. I never use the other line. So even though if I have this situation and I isolate it and then use the same line, I now have this situation. So that's why you always use two separate lines. If you isolate one, plug it into the other one. Okay. Now, we don't say the answer is all real numbers, right? The reason why it's infinite solutions is because, first of all, my answers are points, right? This right here is a point. So if you say all real numbers, you're like, but my answers aren't numbers. And basically, you can't say all points because This is not a solution. The solutions are every point that is on this line. So that's why the easiest way to say is, there's an infinite number of solutions, all on this shared line. Okay. Now, let's say I give you a different problem. So go ahead and do substitution. I already isolated the y stream. Okay. Take this value, put it in there. So then you'll get 2x plus 4 is equal to 2x plus 3. So I'm going to subtract 2x from both sides. You can also subtract 4 or 3 from both sides. It doesn't matter. The key thing is that you'll get a false statement. So I have no variables. I have a false statement. So this is no solution. Okay, let's take a 10-minute break. We'll come back and we'll do one last problem that has a little bit of decimal, not a lot, but a little bit of decimal. We'll play with it so you're comfortable in your homework. And if you go, on my test, are you going to put a lot of decimals? And the answer is no. I mean, X, Y, Z will change the numbers, but I'll try to pick one that doesn't have any decimals. Okay. Now, X, Y, Z may mess with me, but the intention is to give you something that doesn't have decimals. But I do have 2 questions with decimal on your homework, because in real life, you're going to get decimals. But in real life, you're not solving this by hand. Okay. Thanks, everyone. Let's come back at 9:15.
Hello and welcome to Tech Deals. What happens when you turn the RGB up to 11? This happens. This is the edited version of the BitPhoenix Ultimate RGB build. In January of 2020, we live streamed the construction of this computer over the course of 2 days and 4 hours because it seems that speed building isn't my thing. Actually, that's not totally true. I enjoy chat interaction during live streams and I enjoy taking my time with my builds. And I've never done one with 11 RGB devices before, so this was an interesting build. Since most of you probably don't have 4 hours to watch me slowly put together a computer while fumbling around with zip ties, today we bring you the 18-minute edited version with just the highlights of this build. Linked in the video description below will be the full playlist on this build. The 2 live streams that we did back in January are on there, this video, and then the upcoming all the RGB video. We're going to show you the RGB software in various different modes and how it actually looks with all the lights turned down and all the various pretty effects that you can add. Now, that's what it's for. I will say that this computer has caused us no problems over the past 6 months. Quiet and very pretty with all that RGB. BitPhoenix may not be known as the most premier component company in the industry, but the value for the money of this RGB cannot be beaten. I will also say that my lovely wife Rogue has used this as her gaming computer on the ViewSonic 34-inch ultra-wide computer that we previously covered on the channel, and over the past 6 months it has been fuss-free, which is a very nice thing to report. Okay, real talk time, putting the script aside. The Ryzen 5 3600
let's get
plus an
started. Let's
RX
do one more.
5700 is probably
let's do
the
one with
absolute
decimals.
steal of the business right now.
There's
Price
no
to
difference. You
performance,
just
value
do the
for the
same
money,
thing.
a $1,000 build with a decent case, quiet.
Okay, so let's do, can I have a good one here? Yeah, let's do number 4. Let's do number 4. Okay, so if you start with decimals, you're probably going to get a decimal as an answer. Now, some of you doing this may see a shortcut. Go ahead and use it if you want. I'm just going to power through it just because I want you guys to sort of see just the general way to attack this problem. So figure out which one of these x's or y's you want to isolate. Pick the one that doesn't give you fractions. So you can divide, if you divide this by 2, you'll get a fraction. If you divide these by 5, you'll get a fraction here. If you divide these by 2, I won't get a fraction there. I'll get a decimal here, but that's probably the best I can hope for. So go ahead and isolate this one. Okay. Now again, if you can't figure it out, isolate anyone, and if you get a fraction, just deal with it. Okay. But from looking at your homework, you should be able to find one that doesn't give you a fraction. this one. We're going to isolate that 2x. So I've got to bring the 4y to the other side. And I get minus 2x is equal to 4y plus 3.4. And then we divide everything by minus 2.
Professor?
Go ahead.
I'm sorry. I guess I'm not really understanding this part. How exactly are you choosing to isolate? Like, what is the step to isolate?
Okay.
Getting it off.
You're asking the right question. Okay. So I have the option. Okay, let me write this down 4 times. Of either isolating this x, this y, or the x and the y on the bottom. Okay. Now, what you want to do is say, if I isolate this x, at some point, I'm going to divide everything by minus 2. Now, that gives me a fraction. I hate fractions.
Okay.
All right. Over here, if I isolate this y, I'm going to divide everything by minus 5. See how this doesn't divide evenly into there?
Yeah.
I get a fraction. I don't want to deal with that. Over here, if I'm looking at the bottom one, if I divide everything by minus 2, well, I get a decimal here, but that too bad. What I'm trying to do is prevent from getting a fraction over here.
Okay.
And since this right here divides evenly, that's probably my best bet. Right?
Oh, I see. Okay.
Is that better? Okay.
Yeah.
And then when I do this one over here, I get a half over here, so that sucks.
Okay. Okay, perfect.
Okay,
Thank you.
Okay. Now remember, this is the one we isolated. So these are the 2 that we're going to use. Okay, these are the 2 that we're going to use. Right? Use this one and the other line. So the 2 we're working on is the top and this one down here. Okay. So we're going to take this value, we're going to pop it in there. So anytime you do a substitution, you put a parentheses around the variable. And then I'm going to put negative 2y minus 1.7 there. Okay, so go ahead and deal with that. And then you have 4y plus 3.4 minus 5y. Yes. So then this gives you minus y. I'm going to subtract both of these by 3.4. You get minus y is equal to 0.4, and then divide both of these by minus 1. Okay, and then I would probably just plug this back into what you substitute. That's probably the easiest one. And then if you're having trouble with the decimals, just remember you get to use a calculator. So go ahead and just use a calculator. So then you get x is equal to 0.8 minus 1.7. And then we're done. Okay, so while you're working on this, let's talk about the great calculator debate. Should we have a calculator in our math classes or not? See, if you had a teacher who's really like vehemently against calculators, they're about my age. In every one of my classes, until this new law has passed where we're not allowed to teach pre-algebra, I've never allowed anyone to use a calculator, ever. Not in the hardest classes I teach, no calculators. Okay. Now, if you look at our department and you go like, well, who believed like me? Well, everyone else my age. And if you look at people who are about 10 years younger than me, so I'm 52 right now. So everyone between 45 to 60 is militant against calculators. And the reason why is really economics. See, what happens in the early 70s when I went to grammar school was the first time we had cheap calculators. Until then, calculators were really expensive. So not every kid could have a calculator. Or if you had a calculator, it went to work with your dad. But in the 1970s, Japan created very inexpensive calculators. And all of a sudden, teachers felt very scared. Well, why are we teaching decimals? Why are we teaching percents when the calculator does it? So, like any other time when people are scared for their jobs, what happens is we go and say, calculators are bad. They're bad. They make you bad at math. You should never use a calculator ever, right? Because teachers are afraid of losing their jobs. They're important because if you have a calculator, most of what we learn all the way up to sixth grade can be done by that calculator. So I grew up under a generation where a teacher said, if you use a calculator, you're a bad person. You're bad at math. You can't amount to anything. You can never use a calculator. And then when I started teaching, I did exactly the same thing. Now, when you talk to younger teachers who are about 35, 45, they use calculators all the time. They go, yeah, use a calculator. So if you have a younger teacher, normally they're like, oh yeah, calculator, of course. Why wouldn't you use a calculator? Because about 10, 15 years of cheap calculators being out, math teachers realize, we haven't lost our jobs. There isn't any less need for a math teacher because calculators are available. So at a certain point, the teachers started changing where we go, it's a lot faster to just do this with a calculator. Because normally I would have spent another 45 minutes teaching you how to divide decimals, multiply decimals, and add decimals, when I could just say, use the calculator, and I really don't care. Let's actually study harder things. So what happened was the state of California then has decided that, people old like Dr. Kawhi, they need to get over it. So if you're an adult and you want to train for a new career, we really shouldn't start with decimals. We should go, okay, great, decimals. This is how you multiply decimals. This is how you do long division. We should just give you a calculator and say, take the damn class, learn statistics, because that's the thing you're going to use. And when you have a job, you're going to use a calculator. So now this next generation between around 35 to 45, that's how old your teachers are, they're very, very pro calculator because they grew up with, oh my God, this makes my life better. The next generation of teachers are using math software in the classroom where they go, why do we even graph? When you graph, it doesn't look as good. We should use GeoGebra and all the software that's out there. When you have a job, we know what you're going to use, software, and we should use software to do a lot of the calculations and talk about what the results mean. So now there's a new fight where people are going, no, hand calculations only with a calculator. But the state of California has sort of forced me now to move away from calculators, and it's probably a good thing because it probably was a waste of your time to learn how to do it by hand. Okay, but if the state of California changed tomorrow, I would make everyone use a calculator just because there's somewhere deep inside of me where a teacher brainwashed me to say this is a bad thing. Okay. 4.2, we are now done. So let's start thinking about 5.1. Okay, so let's erase this. Okay. So we're going to jump around. Polynomials. Okay. Now, the reason why we're going to work with polynomials is because they're one of the easiest things to manipulate in algebra, in calculus, in geometry. They're really easy to use. So a lot of times you'll have a very complex shape. Very complex but smooth shape. And what you want to do is break this curve down into something that's easy to manipulate, right? Easy to manipulate. And those are polynomials. Okay. Now, what a polynomial looks like, well, let's actually start with a monomial. A monomial looks like ax to the n, where A is a real number. N is a whole number. Okay. So when we think about a real number, we're thinking about any number. We're thinking about fractions, we're talking about decimals, we're talking about irrational things that have square roots in them. So a real number is any number that you can think of for right now. Okay. Now, a whole number is just 0, 1, 2, ... like that. So if I have something like this where I go, let me pick a real number at random, 2/3. And then let me pick a whole number, 5. This is a monomial. Now, for the most part in this class, we're going to concentrate on monomials with single variables. But in terms of your homework, in terms of, is this a monomial, is this a polynomial, they'll also have things that have multiple variables. So this is also a monomial. The key is this exponent has to be a whole number. So this part is a real number. This number is a whole number. The exponent.
Professor, you said the key was, what was the key again?
Is that this has to be a whole number, meaning that you can't have a negative exponent. This can't be a fraction.
Thank you.
Yeah. Right. And then I just said things that are very scary. You're like, wait a second. Can I have something that looks like this? And the answer is, yep. Can I have something that looks like this? Yep. Can I have something that looks like this? Where it's a variable? Yep. So we will deal with both of these later in the class, but not today. Okay. Now, a polynomial is the sum of monomials. Meaning that if you add up a whole bunch of these, you get a polynomial. So if I have something like this, yeah, let's just say that. Now, when we say sum, it could be a addition or subtraction. Oh, sorry, this should not be. This should not be next thing. Let me just show you that it could be a positive or a negative. Okay. Now, there are special kinds of polynomials. So let me, a little bit messy, but let me just kind of take this corner. A binomial is a polynomial of two terms, meaning that it looks something like 5x cubed plus 2x squared. Terms are separated by plus or minus. So this is a term, and then that's a term. A monomial is just one term. A trinomial is a polynomial of three terms. So, the book will ask you a question that looks like this. Okay, and then these have three terms. Three things separated by a plus or minus. Let's make that a minus, just so you can see that they can be negative. Yeah. Sometimes it's easy just to write polynomials, and you just get a sense for what it is. Okay. Now let's look at the ones that are a little bit weird. Right. So you'll look at that and you go, how the heck is that a polynomial? I don't see a number here, and I don't see an exponent. Well, even though it's not there, they're there. So even though you don't write the one here and write the coefficient there, they're there. Right? So you don't actually have to see the one in order for it to be a polynomial. Okay? And then the other one that's a little weird is something like this. And usually the part that people don't like is, hey, where the heck is the x? Don't you have to have an x there? And there is an x there. That's an x. So let me just tell you that x to the 0 is equal to 1. So even though it's not there, there's a 1 here and there's an x to the 0 there. Now, at this point, people think everything's a polynomial. So let me give you examples of things that are not polynomials. So if you see something that looks like this, because this is negative, it's not polynomial. You go, I don't even know what that means. I'm like, well, hang out. We'll start talking about that.
Professor,
Yep.
why did you put x to the 0th power?
Because we said that these each thing has to be in this form of ax to the n,
Okay.
where that's a real number, and this is a whole number. So when you're looking at something like this, you're like, this doesn't fit this pattern. I see a number, but I don't see an x. So technically, there's an x here to the power of 0.
Oh, okay.
Does that make sense? So we're saying that each one of these to be a polynomial have to have this format.
Okay, thank you.
Okay. Yeah. So the reason why this doesn't fit that format is that that's negative. So even if I get rid of the y, since that's negative, it's not a polynomial.
Professor?
Uh-huh.
So for it to be a polynomial, it has to have a exponent, basically.
Yeah. Yeah.
Okay.
But even though it's not written, it's there.
Okay, thank you.
Yeah.
So if it's not written, is it automatically a 0?
It's automatically 0.
Okay, thank you.
All right. So then we'll go into something like this. This is not a polynomial because the x has to be in the numerator. And then something like this. No square roots. Or absolute value. So if I wrote something like this, that's not a polynomial because I put an absolute value there. That's useful. You're supposed to give everyone a chance to copy. Okay.
Professor,
Go ahead.
can you understand why a radical and absolute values wouldn't make it a polynomial?
Because it has to follow that form of, so the definition is very strict, where you go, you have to have things that only look like this. This plus or minus another thing that looks like this. If you add anything extra, like a square root or absolute values, it makes it not a polynomial.
Because like once everything's done with, it won't be in that format.
Yeah.
Okay. So
Yeah.
pretty much if you see it and it's like, I can't simplify this down to real number, whole number with a positive exponent, then
Yep.
it's automatically not a polynomial.
You said it perfect.
Okay.
Perfect, perfect, perfect. Okay. Now let's go to this idea of degree. Okay, now I'm just going to tell you what the rule is for finding degree, and then I'll explain why that's important. The degree of a term is the sum of the exponents in the of the variables. Okay. Now it's easier if I just show it to you.
Professor?
Go ahead.
So degree, like x and the variables that you're adding the exponents from don't have to be the same when you're finding the degree, right?
Yeah, yeah.
Okay.
So this is what we would use in, where we use this at? We would use this in Calc 3. Normally what we're going to do in this class is we're just going to use one variable. Okay. So this over here, this term itself is degree 5. This degree over here is degree 2. It's whatever the exponent is. This is the degree 1 term. And this is degree 0.
Professor,
Mm-hmm.
would you be able to explain one more time, like the degree 2, 1, and 0?
Sure.
Is it always going to be in that order, or?
Okay, you say that you're saying a couple of really good things. Okay. One is yes, they'll always be from largest to smallest. Okay, so let me first write that down. Always write a polynomial from bigger degree to smaller degree. Okay, so that's the first thing that you said that's really important, is that we go 5, 2, 1, 0. Okay. Now the next question is, where the heck did the 0 come from, and where the heck did the 1 come from? What we're doing is we're looking at the exponents. So even though they're not there, they're there. So if I said, look at the thing with a 5 in the exponent, you would look at that. Or if I said, look at the thing that has a 1 in the exponent, you will look at this. So whether it's written there or not, it's there. Now, it's No one's going to pay you a lot of money to say, look at that thing with the 5 in the exponent. What you have to do is scare people so they give you more money. Look at the fifth degree, the fifth degree term, right? The thing separated by a plus or minus that has a 5 in the exponent. So if you think of degree, just think of it as the exponent.
Okay, so why wouldn't it be after the exponent 5, the 2x? Why wouldn't it be like 2x to the exponent 4 and then 3, 2, 1? Why did you go from 5 to 2?
Oh, because I just skipped 3 and 2. You don't have to have everyone there.
Okay.
Okay. As long as you go bigger or smaller, you can skip having stuff in the middle.
Okay, as long as you make it to 0.
No. So let me give you another example. Okay. So let's say I give you something like this: 2/3 x to the 18 minus 7x to the 15. So that's still a polynomial. I don't have to have an x. I don't have to have a number by itself.
Okay.
Okay. As long as it has the form any number, variable, exponent, positive exponent, I'm okay.
Okay.
Okay. So this one over here is degree 18, and this term right here is degree 15.
I see. Okay, thank you.
Better? Okay. Now, so you can talk about degree in terms of individual terms. Okay, so the key word here is the degree of a term. Okay. Now, the degree of a polynomial is the degree of the largest term. Meaning that the degree of this individual term is 18. The degree of this individual term is 15, but the degree of the entire polynomial is equal to 18.
And that's only in polynomials, like a binomial and a trinomial. If it's a monomial, you just add all the exponents.
Yeah.
Okay.
But even if this was in here,
Mm-hmm.
you always name the polynomial by its highest degree.
Right.
So this one right here would be degree 5. So that whole thing, you just pick the biggest one. Okay. Now I know what a lot of you guys are thinking. You're thinking the same thing I'm thinking. Dr. Kwai, I really don't care. I don't care about the word degree. I don't see how this will matter in my life. This can't possibly matter in my life. And normally I would say, well, it matters a lot in my life, but I do a lot of programming, a lot of like creative math stuff. Well, I used to. I'm just a teacher. I do the same thing over and over every day. But back in the day, I used to use this all the time. But the Trump organization gave me a beautiful example of where degrees are used and how using a particular degree have killed tens of thousands of people within the last 4 months. So let's look at it, okay? Because you go, I know you're thinking, This has no bearing in my life. And normally I will say, yeah, but today's actually a special day. I watched the news today and there was something interesting that happened. Okay. So let's talk about this. None of this is on your exam. Oh, this is on your exam. But what I'm going to talk about right now is not on your exam. Okay. Now, the normal course of this lecture then goes, let me show you where degree is used if you're an engineer. Right? So if we look at a line, you know what this is? That's a polynomial. Degree 1. Right? So this is the degree 1 polynomial. That's what a line is. And it looks like that. And if this is positive, I go up, right, because of slope. And if my slope is negative, I go down. Right, that's my slope. This is my y-intercept. And that I know that I hit that through 3. Okay. See, the whole point of us naming these things is to give you the easiest, most important information as fast as possible. So let's look at something like this. So that's degree equal to 2. And degree equal to 2 look like parabolas. They look like this, or they look like this. And that I know that this thing is going to look like this, right? See how that's positive? See how that slope goes up? I have to pick the one of these that goes up at the end. And my y-intercept is 7. Well, how about this? I could put a square there, but I just want to show you that you don't have to have every term there. That's degree equal 3. Now understand that the degree tells you how many times you change direction. Degree minus 1. So I have degree 2, so I change direction 1 time, 1 less than 2. Degree 3 means I change directions 2 times. This either looks like this, see how I change direction and then change direction, or it looks like this. Right? It changes direction twice. So what does this look like? Well, I know my y-intercept is 7, and that's positive, so I got to pick the one that finishes with this going up. So it probably looks something like that. We call this a cubic. A cubic changes direction twice. Okay. So the nice thing about polynomials is that using this information and using the degree will tell me what my shape looks like. How many times do I change direction? The constant at the end will tell me what my y-intercept is, no matter how many, what else is here. Now, remember the word cubic. The cubic changes direction twice, meaning that if I use a cubic, if I'm going up, it eventually goes down. Now, we try not to use cubics for prediction. We try to use parabolas. The reason why is that, let's say I have some curve like that. And what you want to do is make some prediction is what's going on. And what you're supposed to do is you take 3 points and you fit a parabola and you say, I think we're going in that direction. The reason why the parabola is nice is that it takes into account acceleration. Okay. Now, depending on which 3 points you use, you may get entirely different predictions. Over here, I guess that my stock was going to go up. Over here, I guess that my stock was going down. And they go, well, that's where the art of math comes in. Maybe as a mathematician, I shouldn't be the one picking 3 points because I'm going to pick 3 random ones. That's when you go and you find an expert. Hey, you're an expert in COVID. What are the 3 moments that are most important in terms of trying to determine whether infections are going up or down? And you go to the CDC and you say, pick the 3 points. Go pick the 3 points. As a mathematician, I finish the curve and I say, in the near future, I think this will happen or this will happen. And that's why, one, you need mathematicians to do the curves, but you also need people who understand the model. These green points are more important than these red points, which is why we think this is what will happen. Okay. Now, the reason why you don't want to use a cubic is that it changes direction twice. Just because this goes up doesn't mean it's going to go down magically. Right? Sometimes when your company is losing money, it just loses money and it never bounces back. That's why we like to use parabolas to make this, to make our predictions. Okay. Why? How the heck does this affect my life? Well, let's talk about it. All right. This was on the news right before class started. Okay, let's share screen. Okay, so let's go here. Okay, and then let's go Kevin Hassert. Who the heck is Kevin Hassert? Kevin Hassert is one of Trump's economic advisors. He has no background in making a prediction for COVID. Now, Donald Trump thought that COVID would end on May 15th. And if you listen to Pence and you listen to Donald Trump, they had said, hey, May 15th, it's going to be over. No matter what we do, it's going to be over. I get that all these different people have their models, but we have our model. It's the Kevin Hassert cubic model. Okay. Now, people have asked the Trump White House, could you show us your model? And he says no. But as soon as he said cubic, I knew that that Kevin Hassert had played a game. So let's talk about it. If you look at, let's see. Now, just to explain what Vox is, a lot of you guys are new to a lot of topics, right? That's why you're here to college. I'm here to learn things. I don't know a lot of things. I'm here to learn things. What Vox is an explainer site. It's not left leaning. It's not right leaning. But what happens is when you pick up the New York Times or the Washington Post, they expect you to know things. They expect you to be following the story. And they told you yesterday night, this is what happened. And for a lot of people, it's very hard to start understanding something because I don't know anything. So if you tell me what happened yesterday night, I don't have enough background to follow the story. What Vox wanted to do was to say, what we want to do is we want to be an explainer site, meaning that we assume that when you come and read our article, you know nothing at all. And what we're going to do is we're going to explain these things that are in the news from scratch. So if you want to understand anything that's on the news, you go like, I have no background in it, Vox is probably one of the best places to start. Okay. Now, let's look at the Kevin Hassert Vox model. So that's right, the Kevin Hassert model. Okay, now there's two ways to attack this problem. So Nate Silver from 538. So Nate Silver is a statistician, and he was able to accurately predict exactly which states would go for Obama and which ones would go for Romney, and he was perfect. And he doesn't have any money. He's a reporter, and just using really basic pre-algebra, he made the prediction and explained it to everybody, and he was perfect. Now, during the last Republican primary, when Trump won, he said, "There's no way Trump can win." And then Trump won the primary, and then he goes, "You know what? I made the classic mistake. I didn't look at the data. I just go, look at this guy. This guy's a clown. He can't win." So then he went and sat down and did the modeling. And then right before Trump was elected, he said Trump has a 1 in 3 chance of winning, and Democrats 1 in 3 happens all the time. So just so you know, I'm not saying it's likely to happen, but I'm saying it is not an uncommon thing to happen that Trump will get elected. Now, he got attacked by Princeton, by all these Ivy League statisticians, and at the end, he said, "Let's look at what happens. Let's look at the margin of victory." And at the end, Nate Silver was right. Okay, so Nate Silver made a prediction of, let me guess what they're doing. See, what happens is you collect data on how many people have COVID. Okay. Normally, what you do is you put a line there. So you can sort of see the trajectory. See, some days are bigger than others because on weekends, a lot of times people don't do paperwork. You have less staff. So you have a big paperwork on Monday of people who passed away or who became infected. So sometimes you'll get these little jumps or little drops only because more people are around on Monday to do my paperwork rather than Saturday or Sunday. Well,
Professor,
yeah, go ahead.
the screen share is frozen on my end. I don't know.
Oh, is it? Okay. Let me try it again. Thank you for letting me know. Okay. So a lot of times what will happen is you'll have the data and it'll be noisy, right? Because people don't work consistently every day. Every day, who is available, who reported, blah, blah, blah. It changes. That's why you get these little bumps. In order to understand trajectory, what we normally do is we put a line there. It's called line fitting, best fit curve. And it tells us the general shape of what's happening. COVID is going up. We don't know when it's going to go down. Okay. Now, what Hazard did was he did a cubic, meaning that anytime you have something that's going up, it will always go down because the shape of the geometry is using, because he's using a degree 3 polynomial, it will change directions twice. It'll change directions here, it'll change directions there. Now, because he uses a 3rd degree polynomial, he goes, May 15th. Now, his data told him that the COVID is just going up. There's no real sign that it's going down. Because he used a degree 3 polynomial, that has to go down. It has to, because that's the kind of curve he's using. He could then go to his boss and go, "Hey, Donald Trump, yeah, I've got a model that uses math, and May 15th, we're good. We're good. May 15th, we're good." Okay. So this is the Hazard model. So just so you know, as soon as Kevin Hazard used a cubic, anyone who studied any kind of math up to the level of algebra knows that he was scamming. He was telling the president what he wants to hear. And because of that, the entire government went and said, we don't have to do anything. May 15th, it'll magically go away. Okay. So if you ask me, hey, Dr. Kawhi, this whole degree thing, does it matter? Well, yeah, it matters. Because if you hire someone and he uses a cubic in his prediction model, just know he's telling you what you want to hear and he's ripping you off.
Professor?
Uh-huh.
Will we be doing graphs like this in this class?
No, we won't. We'll be doing this one.
Okay.
This one you're going to do in calculus. Yeah.
Okay.
This one you'll do in calculus, but we'll be doing parabolas.
Okay.
Okay. Okay. Now we're going to finish this section up. We did all the heavy lifting. Let's take a 10-minute break. Let's come back at 10:25 and we'll knock this puppy out. Okay. Oh, by the way, and then Kevin Hazard fired today. You know, you can only lie to your boss so often, and then after you sort of embarrassingly tell him to announce May 15th is the end of COVID, you're going to get fired. Okay, so let's get moving on this. Let's go. Okay, yeah. There's two things that we have to do. One thing that we've done before is learn how to substitute into a polynomial. Okay, so let's do this one, and then let's say find. What we'll say compute. Now we'll say find. Find works. Okay. So you're going to plug this -2 into here. Okay, now remember, anywhere where there is a parentheses, a variable, put parentheses. Okay, now plug in -2 into each one of these. See what we get. Okay. So the first thing you want to do is you want to do the exponents. Figure out what this is, and figure out what this is. Now between this 2 and that parentheses is nothing, so we assume that it's a multiplication. -2 cubed is equal to -2 times -2 times -2. Now these two turn into a +4, which equals to a -8. So this part right here, that green, turns into a -8. And then -2 squared is equal to -2, -2 is equal to 4. And now, in between these two things is a multiplication, so you got to keep it, right? 2 times 4. Okay. And over here, this negative times negative turns into a +2. Now, the next thing you want to do is you want to do your multiplications. Now, see, between this -8 and this 2 is an addition. So after I finish the multiplication, I'm either doing an addition or a subtraction. So I have -8. 2 times 4 is a +8. Okay. So if in between these is an addition or a subtraction, after I do my multiplication, I should be doing an addition or a subtraction. Okay, let's try that one more time. Actually, let me make this a little easier like that. Okay. So find f of -3. Okay, so this turns into, right, anywhere there's an x, put a parentheses. And put -3 in that parentheses. Okay, so figure out what this is. Figure out what that is. Now let's remember that that negative is not connected to the parentheses. Right? It's just going to come down. And negative times negative is positive. So then this will turn into what? -9. Okay. Now we have -3 times -3. Now in between these two things, there's a subtraction. So after you figure this, whatever this is, I should have an addition or a subtraction. So this one will turn into negative times negative is +9. And then that'll give me 0.
Professor.
Go ahead.
So basically, all this is basically doing the exponent within parentheses
Yep.
and doing like the regular distributor property, right?
Yep. You're doing the order of operations. So a lot of you guys grew up with PEMDAS, or please excuse my dear Aunt Sally. Essentially,
Okay.
that's what you're doing.
Okay.
Yeah.
Thank you.
Okay. So you should be able to do this. I'll definitely give you something with a negative number so you learn how to deal with this. I need you to know how that you put parentheses around it when you do the substitution. Okay, now. So let's go to something a little more intuitive. Okay, this is 5.1, right? Okay. All right, now, let's just use our intuition. Okay. If I have a cat plus two catfish plus 5 cats. So imagine you go on Tinder, you say animal lover, right? And you ask this woman, like, oh, so you go out with her, you're like, oh, so what pets do you have? Like, I got a cat, I got 2 catfish, and I got 5 cats. And a couple things race through your mind. The first thing that raced through my mind is, what the hell was wrong with that first cat? And then the second way is, why did you say it that way? Isn't there an easier way of saying it? Could you say it in a more simple way? And you go like, yeah. If I ask you to say this in a simple way, you would say, I have 6 cats plus 2 catfish. Okay. Now, when you go, I have a cat, we assume when there's no number here, there's only one of these. So if you go, I got a cat and I got 5 cats, a more simple way of saying it is that you have 6 cats, and if there's no number here, we assume that it's 1. Now, we cannot group the cat and the catfish together because even though this has a cat in it, they're not the same thing. This has to be exactly the same as this in order for us to combine them. Okay? Now, let's sort of use this logic for polynomials. So let's say I ask you to simplify this. 5x plus 2x squared. Oh, sorry, let me go. X plus 2x squared plus 5x. And let's make it even weirder. Let's put a cube there and a cube there. So when I'm asking you to simplify, what I'm asking you to do is, hey, could you put the things that are the same together? Like this cat and 5 cats, could you group them together and tell me how many you have? So I've got one of these x cubes, and I got 5 of these x cubes. So you go, how many x cubes do I have? I got 6 x cubes. Now, you can't combine these because we have a cat-catfish situation. This has to look identical. Looking like it is not good enough. So this and this are exactly the same, which is why we can add them. This right here, even though it looks similar, unless it's exactly the same, we can't combine them. Okay. Now, there's sort of 2 ways in which this homework is going to ask you this question. They'll first ask you it like this, and then they'll ask you something like this. Like that. Oh, and let me make this a square. Now, notice that in between, this is a plus. You can just drop the parentheses. So now you have 2x squared minus 3x plus 4 plus 5x squared minus x minus 7. Now, if you wanted to, you could move things around so that terms that are the same are next to each other. But if you move things around, just know that the operator goes with the term on the right. So this plus goes with this 5x squared. This 4, that plus goes with the 4, and that negative goes with the 7. Now, if you see it this way, you can just write your answer. But for some people, when they're first starting out, it's hard for them to see it. So what you can do is you can put things that are similar next to each other. Just remember that this operator, the plus or minus, goes with the thing on the right. So figure out what that is, figure out what this is, and figure out what that is. So you should get 7x squared minus 4x, right? So even though there's no number here, this is really minus 3 minus 1. That's what you're looking at. Okay? Minus 3 over here. And then that's your answer. Let's try it again. Okay, try that. Okay, so let's oh, this is a square here. So let's see. We're going to combine this with that. And we're going to combine this with this. So you get minus 7x cubed. And if you want to move things next to each other, you can. So I get minus 7x cubed minus 3x squared minus 2. Okay. Now, for people who've done math recently, you're probably bored. For people where this has been a long time, this tends to be something that's really hard to do, being able to sort of see how this operator goes with this and seeing how these two will add to become minus 3x squared. So a lot of times it just helps if you have color pens or pencils or a color marker, go ahead and do that, and it usually pops out better. So I'm working with my daughter. She's never done this. This is the section that we're stuck on right now. So she's just kind of learning how to see it this way, and it takes a little bit. So for some of you where you go like, this is really hard for me, yeah, it's really hard. With my daughter right now, with my son, he saw it right away. I showed it to him. It took all of 15 minutes. With my daughter, we're probably in our 4th hour. And it's just some people are better of seeing this than other people. Okay. Now, if you were to say, hey, Dr. Kawhi, what's the thing you're most likely going to put on the test? It'll be something that has a subtraction that's in between. And now, when I have the subtraction there, what's really going on is that I have 5x squared plus 6x, and I have like a -1 that I have to distribute. Now, it's really subtle. Okay, so you have to distribute this, and then you have to distribute that. And then let me also make this an x, so it will pair up with that. Okay, so go ahead and distribute that. You should get a plus 2x on the end. So I should get 5x squared plus 6x. Like that. Now remember, that minus goes with the 7x. So go ahead and see if you can do that. Okay. Now, if you made a mistake, it's because you didn't make that a plus. Okay, so you get minus 2x squared plus 8x. So on your exam, I'm almost definitely going to make sure that's a minus, because if you could do this one, you could do this one. So put a little star next to it that I'm definitely going to ask you this question. Okay, and it comes up in your homework around 3 times. So just be aware that when you're taking the exam, it'll be there. I'll also put it on the practice quiz, so you get used. So you'll, if you are not aware of it, you'll get it wrong on the practice quiz. Okay. We have one last piece for section 5.1. Normally they cover this at the end of the, almost at the end of the class, but for some reason, the people who set up X, Y, Z, they set it up here, which is not a big deal. It's not a bad place to have it. It's just traditionally we don't cover this yet. So let's just talk about this. Okay. Now, well, actually, let me give everyone like 30 seconds to copy that and move forward. Okay, so let's talk about this last little part. Now, let me sort of justify why it exists. Okay, and for those of you who become programmers, all this function stuff we're doing is essentially what the language of programming is. It's when you learn C++ or C sharp, you're essentially using function notation that we just learned. Okay, now, let's say we go back to my original cost example. So let's say I hire someone. So I'm going to hire someone. I'm going to pay him $10 an hour. Yeah, I'm just going to pay him $10 an hour. We'll make it easy. Okay. Now, when that person works for me, I have to sort of pay his benefits. I have to pay for his desk. So there's these extra costs. So we'll call it infrastructure. Right? I've got to buy him a table. I got to pay for his electricity. Someone has to clean the area that he works in. So we're going to say it's $5 plus 5 times however many hours he works. Okay, so I have two functions. So as a team leader, I only care about this. That guy cost me $10 an hour. But as the owner of the company, I'm in charge of everything. I'm in charge of the electricity, the water bill, the internet bill. That guy, in order for me to figure out the cost of that employee, what I end up having to do is add these two things together. And if you're building a program, this is what a payroll program would look like. Okay? Where the owner is responsible for this, the HR person is responsible for this, and the team leader is responsible for this function. Okay. Now, whenever we do math or we do computer programming, because this is what computer programming looks like, the most important thing is don't have people enter the same number in two different places. Do you see how what if I put the wrong number? These two are always supposed to be the same number, right? The number of hours for here, the number of hours for here is supposed to be the exact same number. But I have a potential to make a mistake of putting one number here and a different number here. If these numbers are supposed to be the same, then I don't want to write it like that. I want to write it like this. Sorry, cost plus infrastructure. Okay. What I would rather do is have only one place to type in hours. Because if I put in a different number here and here, I have an error and it's unnecessary. If this and this have to be the same number, what I want to say is plug this into both of these and then add them together afterwards. Okay, so let's look at an actual problem. Okay. So I'm going to say f of x is equal to 10x. I'm going to say g of x is equal to 25 plus 5x. And then I'm going to ask you to find f plus g of 2. Now, there's nothing new here. The only thing that you have to do is know that this is the same thing as this. This and this mean the same thing. Whatever operator is in between, you just do that. Okay. So separately, you can figure out what f of 2 is. And you can figure out what g of 2 is. And once you do that, you put both of those values here. Now, whatever operator is here goes here. So if it's a minus, that's a minus. If it's a multiply, it's a multiply. So let's try another one. All right, so now you're doing a division. Okay, so this one is here. So I have f of 4 is equal to square root of 4 is equal to 2. Then I have g of 4 is equal to 2 times 4 minus 1. Okay. So this will be equal to f of 4 over g of 4 is equal to I'm sorry, 2 over 7. Okay. Now, let me erase this part. Okay. Go ahead, copy that. Okay, now, as a boss, right, I'm trying to really understand how my company is set up and what my cost structure is, right? So when I look at the cost of employees, it's equal to the cost of the hours plus infrastructure per hours. Now that's nice. It tells me the large theme of what these are equal to, but it doesn't really give me a sense of what am I really paying? Is there a way in which we can simplify it? And you go, yeah, sure. Cost is equal to 10 hours. And my infrastructure costs 25 plus 5 hours. $5 per hour. Okay. So an easier way of understanding what my cost is as the boss is, well, I can combine like terms, and this is equal to 15 hours plus 25, and then I'm done. So as a boss, you could think of these as two separate things, where two different people are responsible, but at some point we go, I want to get a handle on what it actually costs me to hire someone. That's 25 bucks plus $15 per hour. That'll tell you what employee costs. You go, okay, I understand that better. Now, to see how this is represented in our homework, it'll look something like this. F of x is equal to 10x. G of x is equal to 25 plus 5x. Find f plus g of x. Okay. Now, previously, we had a number here. So we would calculate the number and then do the operation that was in between here. In this case, I just want you to add these two functions together and then tell me what you get. Okay. So in this case, I would get 10x plus 25 plus 5x. And when I simplified it, I would get 15x plus 25, and then I'm done. So this gives me the, you tell me an hour, and I'll tell you how much that employee costs. So this is basically saying, take these two functions, add them together, give me a formula back. Okay, so let me give you another problem.
Professor,
Go ahead.
how is the G25? The G times X, is that, are you saying like it's, so if you break it down, the F would be equal to 10x and G would be equal to 25? I guess that's
Exactly. So let me actually do exactly what you're saying. That's probably a better way of my framing it. This is equal to f of x plus g of x. And then this part itself is equal to 10x. And this part itself is equal to 25 plus 5x. Now, technically, anytime you do a substitution, whether it's a variable or a function call like that, you have to put parentheses around. But in this case, they don't matter, and you'll get 15x plus 25.
Oh, I see. Okay.
Is that better? Yeah, I think you framed it better than I did.
Okay, thank you.
So remember, technically, there's parentheses around them. Okay, they don't always matter, but they'll matter if I give you a problem that looks like this. Okay, so go ahead and do that one. Now, so this will turn into f of x minus g of x. So we'll get 2x squared plus 3x minus 7, and then we'll get 5x squared minus 8. So what I have to do is I have to distribute this minus. And then I'll get 2x squared plus 3x minus 7 minus 5x squared plus 8. So now you'll get minus 3x squared plus 3x plus 1, and then we're done. Okay. Let's go to section 5.2. Okay, so 5.1 is done. Let's go to section 5.2. And we got 15 minutes left, so we're going to start with the weird stuff. So let me just, let's start with the weird stuff. Okay. Now, I'm going to erase this. Erase this right here. Now, what we're going to work on is exponents. Now, when we get an exponent, it'll be something that looks like this, where, well, let's put an x here. Where this is the exponent, and this right here is the base. And let everyone catch up. Now, most people are comfortable with 3 squared is equal to 3 times 3. And most people are like, I'm good with that. Okay. And then let's say, let me make it a little harder. What if I make it negative? Try that, see if you can get that. We talked about it before. Let's just make sure you can understand that. Okay. Probably about 2/3 of you will remember that, okay, that negative is not connected to the 3. So I get negative 3 times 3 is equal to negative 9. Okay, so here's one problem. And then here's the next problem. And at this point, some of you are thinking, well, it's almost time. I should just go. Don't go yet, because let me do the weird thing. So now the question is, what's this? And all of a sudden, there's a whole bunch of people who go, -6? Oh my God, no, not -6. -9? The answer, no, not -9. Maybe -9? And the answer is no, it's not -9. So I want to make sure you understand that this is not the same as this. This one has a negative in front of the base. This one has a negative exponent. What this means is change level. So by change level, I mean that if I have something that looks like x squared y to the -3 over a to the -4, b to the 5, what I want to do is everything that is negative, it changes level. So x squared a4 y cubed b5. Now the b can come first, the a can come first, that doesn't matter. Well, what the negative means is change level, and then the exponent becomes positive. Now, once they change level, these now become positive. So over here, this 3 is in the numerator. What I need to do is change level. This goes to the bottom. And then this turns into 1 over 3 times 3 is equal to 1 over 9. Okay, so let me let you do a few of these. Okay, try those 3 problems. Okay, and then I just want to give people a heads up. I have a meeting that I have to go to, luckily on Zoom, at 11 o'clock on Thursday. So just want to give you guys a heads up on Thursday. I'm going to leave a little bit early, so I won't be able to take. I'm going to leave right at 10:55, and then I have to check down the room at 10:55, and then zoom into a meeting. So normally I would never go to a meeting during class, but there's a half an hour overlap. School, after all the George Floyd stuff has happened, the school is trying to figure out what our response should be. I mean, there's a lot of things that are going on. Should we keep the sheriffs on the campus, or should we hire a private security firm? How do we have a reporting procedure that if a teacher is inappropriate with a student in terms of their comments, how do we report it? How do we do guidelines? What is okay? What is not okay? How do we train teachers? So because this is one of those planning meetings, and normally nothing happens at these meetings, but because right now a lot of professors are really moved by the protests that they see outside and would like to see that change happen at Valley College. I really want to go to this meeting just to make sure I get my 5 cents in. Okay, so I just want to give everyone a heads up. On Thursday, 10:55, we're just going to do a hard cut. And then if you have any questions, ask me Thursday morning, or on Friday, I'll hang out as long as you want after class. Okay, so that's not tomorrow, that's Thursday. So let's look at this. Now, let's remember that this one right here, the negative is not connected to this number. So we're doing the exponent first. Okay. And then over here, this means change levels. Okay. So you're never evaluating something that has a negative exponent. We're always moving it. Now over here, you're doing the same thing. Your negative is not connected. And then we're going to change level. And then this becomes positive. And for a decent amount of students in class, I just raised your blood pressure. Let's take a picture. And if it helps at all, tomorrow morning, just show up on time, and we're going to start this all over from scratch. Now, let's look at the other weird thing. The reason why we're going through the weird things is that I want you to get comfortable, because the second time you see it, it's a little bit easier. The first time, you're just kind of like freaked out. So let's say I have something like this. Anything to the 0 power is equal to 1. So 5 to the 0 power is equal to 1. Okay. Now, people used to think that was equal to 0. And then someone went and had a conversation, and then all the mathematicians go, oh my God, you're right. It is equal to 1. So I don't know exactly what that guy said, but tomorrow we're going to go over the reasoning of why that's equal to 1 and why this means change level. So tomorrow we'll go over just the intuition behind it. Right now, I'm just telling you, hey, here's some weird questions. Give them a shot. So anything to the 0 power is 1. So let's try these problems. And then let's go. So let's try doing these 4. Okay, now I know a lot of you are looking at that and going, is everything just equal to 1? And the answer is not quite. Now this one's equal to 1. I agree. And this one's equal to 1. This is saying this whole thing to the 0 power. So you can have anything in here. As long as you have parentheses, it applies to everything. everything in the middle cancels out, just becomes 1. Now, this one and this one are very similar. That negative is not connected to the 5. So this negative will come down and then just become a 1. Okay, so the answer to that one is -1. Okay. Now this one is subtle also. See, in between the 5 and the x is a multiplication, which means that the exponent only applies to that x. So this turns into, so let me actually leave it like that. So even though it's not there, it's there. That multiplication is there. That 5 and that x is not connected. So this turns into 5 times 1, which is equal to 5. So all of these are fair game. Okay, so I want to make sure that you're comfortable with it. Take a picture. And all of you guys are now free. So if you have questions, I'll answer them. If not, you guys are welcome to go. Thanks, everyone.
Professor?
Professor, I have a question.
Sure.
Are you going to be posting 5.2 homework today?
No, you can still access it, but it's not gonna. We just barely started it. It's gonna take us about an hour and a half.
Oh, okay. Okay. Thank you.
Yep.
Professor?
Uh-huh.
Would you be able to explain the polynomial 5 exponent to -2?
Say it again. The polynomial.
No, the one that's on the board right now. It's 5 exponent -2.
Oh yeah. Okay.
5 square.
Yeah.
It's
Weird, right?
Yeah.
Okay. If you have something that looks like anything that has a negative exponent, it means change level. So anytime I have a negative exponent, this one and this one need to change level. So this turns into y squared b to the 5, and then a 4 x to the cube. Now, when you change the level, that's how you make these positive.
So you would just basically flip them.
Yeah.
Basically, okay.
Yeah. So technically, when we have something that looks like this, technically, that's really what we have.
Okay.
And when I say change levels, we're bringing it to the denominator.
Oh, I see. Okay.
Is that better?
Yeah.
It's weird.
And then it would be the same thing for the one that's the -5 with the negative exponent 2, correct?
Yes.
It's negative and it's positive.
Yes.
Okay, perfect. Thank you.
Thank you.
Professor?
Uh-huh.
So yesterday I logged into my XYZ homework website and then I couldn't see my quiz grades in my gradebook. So how can I see?
Let's see. What's your name? All right.
Asmin and Ersisyan.
Okay, let me see if I can see it real quick. So let me jump in there. Let me see if I can see it. And then if I see it, okay, now if I don't see it, don't stress out. We'll figure something out, okay? All right, let me see the grade book. Your last name is N-A, oh, okay.
Nersisyan.
Yeah, I see it. I mean, when you go in there, you can't see your exam at all?
No, it's not saying quiz anywhere.
Oh, okay, let me see. Let me text you what your score is first, and then let me see if I can find it, okay?
And then there was question number 19. So I got the graph right, but the answer was showing that I'm not right. So how's that happening?
It could be. Let me see. All right, let me want to make sure I don't send it to everybody.
Mm.
Right. Okay. It's as meaning, right?
Yes.
Okay. All right, so let me see that one. All right, so I just sent you a private message of your grade, and then let me look at your quiz one. And then let me see your quiz one. I think it saves it for me. No, it didn't. It didn't save it for you. Oh, wait. No, it did. It did. Okay, so all right, so
It's the 19th question.
19th question. Okay, thank you. Almost there. Okay. All right. So I'm going to share screen it with you because you got it right. Okay. No, 19, it gave you credit for it.
Yes, but I thought it would. Oh, okay.
So you're okay. It gave you credit for it.
I don't think it's the 19th. The 19th was
Okay.
1 over 2x plus 3.
Okay, let me find that one.
Okay.
When I scroll through, I don't want to show everyone your test, but you did really well.
Thank you.
Okay. Oh, 1 over
2x, 1 over 2x plus 3 is less than or equal to 1.
Okay, let me see. I don't. Oh, maybe it's this very first one. Okay, wait. Huh. Let me see. The only one I see you get wrong was you have the inequality wrong, right? Let me see. It says, so you got like partial credit on something, right? I'm trying to find it. I haven't found it yet. Let me see. Huh. I don't see what else you got wrong. Was it 19?
Yes, it says 1 over 2x plus 3 is less than or equal to 1.
Oh, I see it now. Okay. So it's this one right here. Okay, let me show screen, right? Okay, this one right here, right?
Yes.
Okay, so let's look at the answer.
The graph is, I don't get how the graph can be right and the answer is not right.
Yeah, I'll just give you the extra point. Don't worry about it. So
thank you so much.
Yeah, no problem. So let me do it right now. Let me full credit. Yeah. Okay. You have full credit on it now.
Thank you. And also, Professor, how can I see my overall grade of my this class?
Okay.
On the grade book?
Yeah, on the grade book. The grade book should show you.
Okay.
Okay.
Thank you so much.
Okay, no problem. Let me make sure I can save this. There we go. Okay, I saved it. Okay. Anyone else have a question?
Yeah, I actually have a question about the quiz. Because on my quiz, for question number 20, it asks for 3x plus y equals 6. For slope, I went ahead and put negative 3 over 1.
Oh, and it didn't give you the point?
And it marked it wrong, even though the answer says negative 3.
Okay, it can happen. All right, so Mitzi, what's your last name?
Natareno, Natareno.
Okay, let me get there. So I owe you another point, right?
Yeah, because I just wrote it like it was negative 3 over 1 because it says slope, so I'm like, I just did that.
No problem. Okay, so let me see. This is for, which problem was it on again?
Question number 20.
20, okay. So let's take a look together. Let me get to it first. All right. All right, so let's, okay, so then Oh, I see why. It wanted -3, not 3/1. Let's just do that. I'll just give you full credit. Next time, just simplify that to -3.
Okay, got
Okay?
it.
All right, so let me give you full credit on that, and then, yeah, and then let me save it.
All right, thank
Okay.
you.
Thank you. Did anyone else have questions?
Professor, I have a question.
Uh-huh. Go ahead.
For mine, it just asks for the slope, but I also put the y-intercept with it. Would that be wrong?
Yeah, you have to just give it the slope because you have to know what the difference between the two parts.
Okay.
Okay.
Thank you.
Uh-huh. Anyone else have a question?
I have a question, Professor. So
Uh-huh.
on the grade book, I have a 48%. Are we supposed to do all the homework, even the sections we haven't done?
No, only the sections I assigned. So what's your name? Your name is
My name is Karina.
Karina. Okay, so I see that there.
I know I missed like 4 sections, so that could be probably.
Yeah, that's where it came from. If you hit late pass on them, it'll let you do it. It'll only penalize you 25%.
Okay.
Okay. So most of your grade is basically your exams. So if there are sections where you go like I could use the help, then go ahead and do it.
Okay. So like as time goes on and we take more tests, the weighted total will change?
Yeah, because it's only 10% of your grade. So right now the quiz is 15%. So homework is almost half your grade.
Oh, okay. That makes sense.
Eventually it'll be worth only 10% because 90% will be everything else.
Okay. Thank you.
Thank you.
Professor?
Uh-huh.
So the question I have, it has to do with the lessons we covered yesterday with 3.4 and 3.5.
Sure. What's the question?
So I just want to know when a question, or how do you know whether a question is asking you to list the domain and range for like all the x's and y's shown in the ordered pairs of that problem, or when it's asking you to put it in interval notation?
Okay, you're asking a good question. So let's look at the difference. Okay. So all right. So there's basically going to be two kinds of problems. There's going to be the one that looks like this. And let me make sure that you can see me. Yeah. Okay. You guys are looking at me. Okay. So domain and range, and then it'll give you points. Okay. Now there's another one where they give you a graph and they give you points. And then let me put another point. There. Okay. And then there's another one where they give you something that looks like, I don't know, like this. And let's say this is 3. Let's say this is -4. Let's say this is -1.
Oh, I see it already.
Do you see it already? Okay.
Yeah.
So for these, you're going to say the domain are just those points.
Mm-hmm.
Range is 3 and 5. And same thing for this one. Domain is 1 and 2, and range is -1, 2. This is the one where you're going to give me the interval. Like that. And the reason why is because it's connected.
Yeah, okay. That makes
Okay, better? Okay. Thank you. Did anyone else have questions?
Yes, Professor. The one that emailed you last night. My name is Sandy.
Oh, okay. Let me take a look. I haven't seen it at all. I have my email right here.
Because I had issues with both of them, where it didn't let me take either one.
So what happened? So let's see, what does it look like when you look at it?
So when I went into the pre-quiz and then the quiz, it let me answer one question, and then it like turned everything red. So I wasn't able to take the pre-quiz or the quiz because it did it both times to me. I don't know if I did something wrong or.
Did you what kind of are you doing it on a laptop? Are you doing it on a home computer?
I'm doing it on a MacBook Air laptop, but I did just move up in the mountains, so my signal's a little crazy right now. And
That might be.
maybe.
And then does your homework work? Like when you
Yeah, my
when you're
homework.
doing the homework, it works.
Yeah, my homework was perfectly fine, but then when I press enter, I guess like I had basically done the entire quiz and like the whole timing frame was like going down, like timing me. But then when I pressed entered, it didn't save any of the problems, and it did it both for the practice quiz and the quiz, so I wasn't able to get any of it.
Okay, let me see what your score looks like. We'll figure something out. Give me one
Because if
second.
you look at the quiz, it just shows you how I entered one question,
Yeah.
and then the rest went blank. So
Okay. Let me see what I see on my side. So it is it Sandy?
yeah, Sandy Balkersel.
So on the so it only lets you see one question?
Yeah, like I entered one question and then the like the actual quiz, it just everything turned red. Like all the answers like highlighted red, and then after I exited it said my time was up, but I was on it just for like I was trying to do the test, and then I pressed save, but it didn't save anything.
Okay, let me try doing this. Let me try making this into a homework problem. Because you said when you do homework you can see it, right?
Yeah.
Okay, so what I'm gonna try to do is I'm gonna try to make it a homework problem where you have like everything will be the same as homework, but it will but it'll have a timer on it, and then it'll just save it for me afterwards.
Okay. So
So
will I be able to take both, or am I just going to be able to take the quiz?
Let's do both, and then
Sorry,
let's do this. No.
I don't want you to think I'm not trying to take the test, but
No, I mean,
tried so many different ways yesterday, it just wasn't working.
When you try using a different what are you using Chrome? Are you using Firefox?
Yeah, I have Chrome and Firefox and Safari. So I
When
tried doing three different, like logging in 3 different ways and then everything. But it just didn't allow me anymore. It just said my time was up. But
okay. Let me do this. Let me change the time so that you can do it again. And let's try this. Try using the different browser. Do you have a phone also that you use or an iPad?
Yeah.
Okay. No matter what, I'm not gonna let you. We're gonna work with you. Probably the easiest thing is let's try having you use different browsers.
Okay.
Okay, and then where are you? So do the different browsers on the practice, and then whichever one works the best. Let's try that with the actual quiz. Wait, what was your last name again?
Balkersel, B as in boy, A-L.
Okay, Sandy, right?
Yeah.
Okay, so in terms of the quiz, let me see if I can reset the time. So I can clear your account, and then we can change your time, I think. Okay, wait. Stay there, because I've never done this before.
Okay, thank you.
Okay, make exception. All right, so I'm going to make this available to practice quiz. Okay, I'm going to make these available to, today is the 23rd. So, all right, I'm going to make it available to by the 26th.
Okay, thank you.
Okay. Now, if it doesn't work, you just tell me and we'll try some other things.
Okay, thank you, Professor.
Okay.
Have a good day.
Thank you.
Professor,
Yeah.
I never taken high school here in the US, so I'm just wondering the class that we're doing now, is it a high school class or a college class or
It's high school.
high school class?
Yeah. So where did you do your education?
I'm from Thailand.
Okay. Yeah. I mean, so in terms of time.